Okay, so thank you very much for including our paper in the program. It has been a pleasure to be here so far. This is joint work with Juliane Begenau from HBS, and she is sitting there in the audience. Okay, so the title of the session is New Answers to All Questions. So let's start from the old question. I guess that many of you are familiar with this Thaler's fact. This is the average cash to asset ratio for public companies in the US. These are annual data from CompuStat starting in 1958 up to 2013. So basically, what is the Thaler's fact that the profession has focused on, I guess, in the last, I would say, 10 years? The so-called secular increase in cash holdings. So what is the secular increase in cash holding? It is a dramatic increase in the average cash to asset ratio of the typical US public company from around 0.08 in 1979 to around 0.24 in 2013. So this is a threefold increase, a very large increase. So what is the old question? The old question is, what are the determinants of such a dramatic increase in this accounting ratio? Well, let me tell this first. This is by no means an exhaustive list of papers that have worked in this direction. So basically, the literature has identified three main mechanisms at work here. First, an increase in agency conflicts and precautionary savings motives within the firm. Then there is basically the fact that there are many multinationals that are parking their cash abroad. They don't repatriate the cash because it's costly to do that. They are going to pay the corporate tax. Then there is changes in the cost of holding cash over time. So the opportunity cost of holding cash over time has gone down, and firms held more and more cash relative to assets. Okay, so what is the common denominator of most of these papers? The common denominator is that this mechanism work within the firm. So basically, you are going to think that the typical US public firms has increased the cash balances relative to assets in the last 35 years. This is not the case, because basically what is the new answer to the old question is basically there is a big deal of selection at work in the data, and this selection is mostly driven, actually I would say exclusively driven by R&D intensive firms that are gradually replacing traditional low R&D intensive firms, and this fact is coupled by a second one, which is, I would say, much more important. These firms, R&D intensive, become public with higher and higher cash balances over time. So what we are going to do, we are going to show you the effect of selection in the data. And then we are going to build a simple industry dynamic model, basically to quantify the selection effect. Obviously, the goal will be to replicate the secular increase, but most importantly, our goal is to understand basically different selection mechanisms at work. And we are just, in this paper, proposing two of them. One is a structural change in the US economy. We know that the US economy has become less and less manufacturing intensive and more service intensive. And the second, basically, selection mechanism is a reduction in the cost of going public for R&D intensive firms. This is a justification that has been used also by Michelacci and others in a paper in the Review of Economic Studies. So we think it can be a plausible mechanism. And the combination, as I will show you when we are going to talk about the model, this combination of effects is able to generate a sizable, can explain a sizable chunk of the secular increase in cash. All right, so this is the roadmap. We're starting with the data. So what is selection and how important selection is. Then we're going to look at the model, and then we are going to use the model as a laboratory to basically explore these different selection mechanisms. All right, so this is selection at work here. The left panel is the following. This is the fraction of R&D intensive firms that are public. Now, I'm using cohorts of 5 years. Okay, so each dot refers to a cohort. In, say, 1970s, around 34% of firms were R&D intensive. And then, over 35 years now, the typical US public company is an R&D intensive firms. 55 of them can be classified as R&D intensive. So this mechanism, this selection mechanism, can work for two reasons. There is an exit margin, right? So basically, this can happen because more and more traditional firms are exiting relative to R&D intensive firms. Let me tell you right away that the exit margin plays no role in the data. All the action is driven by the entry margin. Basically, this, I would call it, okay, a demographic change of companies in Compustat is driven by the fact that R&D intensive firms enter in higher and higher number relative to traditional firms over time. That's not the only important startup fact. The other startup fact is the following. These R&D intensive firms enter, this is the average cash at entry of these cohorts, enter with progressively higher and higher cash balances. In the last 15 years, R&D intensive firms have entered with more than 50% of assets in cash, okay? If you look at traditional firms, for example, in the 2009-2013 periods, the average cash at entry is pretty much the same as in the 70s. So we have a suspect, R&D intensive firms, that are driving this selection mechanism. Okay, so if there is a graph that basically is going to summarize at once, the empirical result is this one. So what is this graph? Each red dot is the average cash at entry of a cohort of firms. Now, the blue line connects the average cash at entry with the average cash of the cohort in 2013. Now, if the within effect is the explanation for the increase in the cash to asset ratio, we are expecting the blue line to be upward sloping. Each cohort will progressively increase the cash balances over time. Now, 1979, that's when basically all the action starts. And we see that they enter with a progressively higher and higher cash, and the blue line is downward sloping. So these cohorts that progressively enter the equity market deplete cash over time. So the fact that this slope is negative tells us that the within effect explanation might be not the right one. Okay, so this is suggestive. In the paper, we do some basic econometric exercises, but what I want to do is something which is an exact decomposition. So this decomposition is the following. Delta cash holdings. This is the change in the average cross-sectional cash holdings between time t and time t minus 1. You can basically reshuffle all these terms and write the change in cash holdings between two consecutive periods as a term that we call the within effect, and this is the change in cash holdings due to incumbents, firms that were public at time t minus 1 and that are public at time t. And then you have an extra term that is the selection effect. This is basically the change in average cash holding driven by exitors, firms that are public at time t minus 1 and they exit at time t, and entrants, firms that are not public at time t minus 1 and enter at time t. So what you can do, you can calculate this decomposition over time, and then you can calculate the cumulative growth that the within effect is explaining and the selection effect is explaining. This is an exact decomposition, so we don't need standard errors around the numbers. Now, the black line on the graph is the cash to asset ratio. The cash to asset ratio went from 0.08 in 1979 to 0.24 in 2012, so a threefold increase. The dashed blue line is the cumulative growth due to selection, negative. So if selection is the only story, we will witness a secular decrease in the cash to asset ratio. If the within change is the only story. Selection, on the other hand, contributes for 0.33. You take the sum that gives you the change in the cash to asset ratio, and you recover the fact that the cash to asset ratio has increased to around 0.16%. So why is this the case? Because firms that are incumbent have decreased the cash to asset ratio at a slower rate than firms that have entered with higher cash to asset over time. And that basically gives us the secular increase in cash holdings. Obviously, you can decompose the selection effect in the contribution of R&D intensive firms and the contribution of non-R&D intensive firms. The bulk of the selection effect, more than 80%, is due to the entry of R&D intensive firms. So this is our basically new answer to the old question. Okay, to wrap up, selection plays a major role. Selection is driven by R&D firms that enter in higher and higher number relative to traditional firms and enter with higher and higher cash to asset ratio. This is key. And after entry, as any other public company, they deplete cash over time. And this brings us to say that the within firm time trend, as I showed you before, is most likely negative. So why a quantitative firm dynamics model? Well, because within the model, we can really explore different selection mechanisms and how these different selection mechanisms interact with each other. And we will see something really interesting, I would say, at the end of the talk. So we explore these different selection mechanisms, and then we ask how much of the secular increase does selection explain, and which selection story or combination of selection stories, selection mechanism, can be the plausible one. Okay, this is a model in the tradition of dynamic corporate finance model that Tony has done. What we bring on the table is the modeling of the entry-exit margin based on the work that I have with Gianluca and the work that Juliane has with Juliane in Minnesota. So basically what we do, we take a decreasing return to scale production function with idiosyncratic shock. Obviously, we want to create heterogeneity in the cross-section. There are two firm types. So now let's call the traditional old economy and the R&D intensive new economy, just to simplify the notation here. The old economy firms relies on tangible capital that can be used as a collateral. The new economy firm, intangible capital, we can assume that this capital is firm specific. It has no use outside the firm. So the R&D intensive firms, the new economy firm, cannot use this capital to raise debt. Financing happens internally with cash accumulation or externally with debt and equity. And then we have the usual financial frictions here. Why? Because we want meaningful deviations from a Modigliani-Miller setup, tax advantage of debt, costly cash accumulation, a collateral constraint that will depend on tangible capital, and then we will have basically linear debt and equity issuance cost. Now, we have endogenous entry, and we decided to model exit exogenously. There is an exogenous exit rate. This can be done without loss of generality, because in the paper we show that the exit margin, it's really not interesting in creating this secular increase. Okay, so two types of firms, old and new. Revenues are a function of a firm-specific shock times capital. Alpha is the degree of return to scales. Idiosyncratic shocks are autoregressive, they are persistent. Capital law of motion is the standard neoclassical capital law of motion. So capital tomorrow is the depreciated value of capital today plus the investment that the firm does. And then we have just quadratic adjustment cost to create some persistence both in investment policy and especially in cash policies in the paper. We are going to assume that the depreciation rate of intangible capital is larger than the depreciation rate of tangible capital. And this is consistent with the Bureau of Economic Analysis estimates. Okay, intangible assets depreciates faster, much faster than tangible assets. Financing internally through cash. So this is the internal accumulation rate for firm J. J can be old or new, and it is going to be less than the risk-free rate to basically allow for a meaningful cash accumulation policy within the firm. Equity issuance cost and debt issuance cost are linear. There is a collateral constraint. Now, here is a little bit convoluted, but let me tell you what this L is. L basically is the face value of debt minus the cash balances at hand at time t plus 1. So this minus L is going, that we call minus L, is going to be the net debt of the firm at time t plus 1. So the net debt, right, cannot exceed the depreciated value of capital for the old economy firms at time t plus 1. So why do we do that? Well, we want debt, and we think that risk-free debt is enough to basically highlight what we are interested in, which is the selection mechanism. And I guess this comes without loss of generality for our results. All right. What is the firm problem? Well, the value of an old, low R&D intensive firms is the financing and investment policy, that maximizes the present discounted value of dividends, subject to the dividend constraint. So this is a budget constraint for the firm. Capital law of motion. This is a law of motion, WT plus 1 equal to after-tax revenues plus, this is now net cash, is the opposite of net debt. And then we have the collateral constraint for the old economy firm. Now keep in mind that the firm can exit at an exogenous rate lambda. Okay? So the firm can die. If the firm exits, then the firm can recover, the wealth plus the depreciated value of capital. We do that just for convenience. We model the exit in that way for convenience. Okay, this is the new or R&D intensive firm. It's pretty much the same setup, the same problem. There is only one key difference, which is this one. Net cash cannot be negative. So we cannot issue debt. This firm can only use costly equity or internal resources to finance investment. Okay? There is nothing new here. This is a model that has been solved in many, many papers. What we add on top of this model is an endogenous entry margin. So you can assume that there is a positive mass of firm larger than 0, and this is the universe of private firm. So private firms can be either new economy or old economy, and this omega there is the fraction of private firms that are of old economy type. Now, IPOs happen in an IID fashion. We are not interested in modeling the IPO decision. We just say that the firm is randomly drawn, and this firm can do an IPO. The decision that the firm faces is to choose the investment and financing policy to maximize the present value of being a public firm. What is the cost? Well, the cost is going to be the IPO cost, and the IPO cost is indexed by I. I is either old or new. So we assume heterogeneity in IPO cost for old and new firms in the economy. Okay. This is the industry equilibrium. Given the share of high R&D firms and R, incumbents of either type solve the problems. Entrants receive the signal and decide whether to enter or not. Firm distribution is stationary and consistent with the Markov distribution of idiosyncratic shocks and the decision of incumbents and entrants. All right. Calibration. I'm not going to discuss the numbers. I'm going to discuss just the strategy. The strategy is the following. We calibrate the economy to the 1959-1979 periods. Why? Because basically we want to completely shut down any within change explanation. So these firms are technologically and financing-wise exactly the same in 1979 and in 2013. We are going to play only with two parameters here. Omega, which is basically calibrated to replicate the fraction of new firms in 1979, 33.2%. And then we're going to play with the cost of entry for new economy firms. We basically calibrate this parameter to match the cash holdings at entry of new economy firms. And then basically we do a decent job in matching both the moments implied by some accounting ratio, and then we pick this exit rate from Compustat to be 7%, and we do a good job in matching the age distribution, and by age distribution I mean years from the IPO, okay? Good. What we do then, we have set up the lab, we can have fun. So experiment number 1, we study the effect of a compositional change. So omega changes over time. Why? The US economy has become less manufacturing intensive and more R&D intensive over time. We impose discipline, right? How do we impose discipline? We basically generate a change of omega to generate a compositional change for publicly traded firms similar to the one observed in the data. Experiment number 2, we reduce this entry cost. What is this discipline that we impose on the exercise? We reduce the entry cost to mimic the dynamics of average cash balances at entry for R&D intensive firms. Experiment number 3, let's see if the marriage between 1 and 2 works, okay? All right, experiment 1, we change omega, and the fraction of new firms increases from 33% in 1979 to around 15% in 2013. The red line basically is the data. So the discipline is tight, and we basically tie our end with the data. What is the increase in the cash to asset ratio? 0. Absolutely negligible. So composition alone is hopeless to generate the secular increase in cash. However, there is something really important that composition brings on the table. This. Composition basically changes the cross-sectional distribution of firms over age. So because of this composition effect, we have more young firms. By young firms, I mean more firms that are closer to their IPO. These young firms, by entering with, being younger, they enter with higher cash relative to old firms, and they deplete cash basically at a slower rate. And this creates this dynamic in cash holdings that is pretty much linked to the dynamical evolution of R&D intensive firms' age over time. Experiment number 2. Well, we reduce the entry cost. Firms enter with higher cash relative to assets. The red wiggly line is the data. If you do this at the yearly frequency, you don't get the smooth results that we get in the data by aggregating at the cohort level. But in any case, the discipline is, okay, this decrease in the IPO cost has to be such that we have around 14% of cash at entry in 1979 for R&D intensive firms, as in the data, and something around 60% in 2013, as in the data. Okay? Now, the discipline is there. What happens to the cash, the average cash holdings? It goes up. Why? Because firms enter with higher cash. There is persistence in cash holdings. Cash holdings go down slowly, and then the cross-sectional average of cash holdings goes up over time. New firm age, nothing. There is no compositional effect over time, so we don't have that. What happens? The change in cash holding generated by the model from 1979 to 2013 is 0.5, 0.05, the data 0.15, 30%. Can we claim success? No, it's too low. So the mechanism linked to a reduction in the entry cost is more powerful than the mechanism linked to the change in the composition of firms, but it does not generate a spectacular, I would say, explanation of the secular increase in cash. What happens when you have both of them? When you have both of them, basically now, this change of the distribution of age kicks in and creates an amplification effect of the reduction in entry cost. And via this endogenous amplification effect, the model is able to generate 0.09 in total change in cash holdings between 1979 and 2013, which is around 60% as in the data. So if you look at this graph, you can say, oh, I've seen that before. Well, this is the theoretical counterpart of the graph that links the cash at entry to the cash in 2013. And basically, the model not only explains 60% of the increase in cash to asset ratio, but basically, it also generates this negative within trend. So basically, we claim that the mechanism that we are after is very much the one that generates the secular increase in the data. Okay. Conclusion. I guess I'm early. That's good. Selection is important for the increase in cash to explain the secular increase over the last 35 years. The structural model explains 60% of the cash to asset evolution, and we didn't push the model to explain more. We can. We haven't done that. We can add additional features like adjustment cost of cash, but we wanted to keep things simple. Oops. The key for the model success is this increased proportion of younger intensive firms that amplifies the effect of higher cash balances at entry. Now, well, you can wonder, why do we care about selection? We care because now the focus shifts from public firms to firms that are going to become public to understand the secular increase in cash. So if you want to understand the secular increase in cash, you have to understand why more R&D intensive firms go public with higher and higher cash to asset ratio over time. And you can say yes, because the saving propensity out of IPO proceeds has gone up. That's a simple explanation. That's not the explanation, because CompuStat allows us to go back 1, 2, even 3 years before IPO, and you can track the secular increase pre-IPO, and we have that feature there in the data. Okay? And this is ongoing work with Juliane. We are going to shift the focus and try to understand what's happening in the pre-IPO period for these R&D intensive firms. So thank you very much for your attention.